All right, welcome to Notes on Solving Quadratics by Completing the Square. So once again, we're learning another method on how to solve a quadratic. So let's really quickly review when we approach a quadratic to solve it, just running through your head how to solve this quadratic right here, okay? First thing you should ask yourself is, can I solve it by square roots? Because it's the easiest method. I see an x squared and an x. The answer is no way. So next I'm going to try to see if I can solve it by factoring. In order to factor it, it has to be equal to 0, which this is. I look for a GCF. There is no GCF here. And then I'm looking for two numbers that multiply to give me a times c, which is -1, and add to give me b, which is 4. That's not going to happen, so I cannot solve it by factoring. So now that I can't solve it by square roots, I can't solve it by factoring, I'm left with one of two methods. I'm left with solving by completing the square or solving by using the quadratic formula. So you're going to learn the method today of solving by completing the square. Okay. So in order to solve by completing the square, first off, you have to have a lead coefficient, the a value that is on ax squared. So this value right here, that wasn't a 0, that was me just making a little blurb, has to be 1, which it is in this case, so that's done. If it's not, you have to divide every term, divide both sides of the equation by that value, which we don't have to worry about. So moving on to step number 2. It says rewrite in the form x squared plus bx plus c. So basically what you're going to do is you're going to take this constant and either add or subtract it to both sides depending on what it is. So since that's a -1, we're going to add 1 to both sides. So now we have x squared plus 4x equals 1. Now what I like to do is I like to leave a little space right here to complete the square, because that's where we're going to complete this square. All right, so now to complete the square, what you're going to do is you're going to take b divided by 2 and square it and add it to both sides, which I don't say b divided, I say half of b. You take half of b and square it. Now, you could do this in your head, right? But I'm going to write it down just for purposes to show you something later. So this is your b value right here. So we're going to take b, take half of that, and square it, okay? So 4 divided by 2 is 2. Oh, I don't like how I wrote that. So that is equal to 2 squared, which is 4. Okay, so that's what you're going to add to both sides. So I'm going to add 4 to this side, but what you do to one side, you have to do to the other, so I'm balancing it right there. Now what you're going to do is you are going to factor the left-hand side, and you are going to simplify the right-hand side. So the left-hand side, this will always be a perfect square trinomial. Sometimes it's easier to factor than others. What do I mean by that is when they're integers and not fractions, it just is easier. But if you look at this, you're looking for two numbers that multiply to give you 4 and add to give you 4, which is 2 and 2. So it's always going to be x plus 2 times x plus 2, or x minus 6 times x minus 6, or x plus 3 halves times x plus 3 halves. So when you're writing it, you're not going to write it as those two binomials. You're going to write it as the binomial squared, all right? So it's always going to be x. And then the reason I wrote this out is it's whatever this number is right here. So this is x plus 2. X plus 2 times x plus 2 squared equals 5. That's helpful for when it's fractions. It's easier to see it instead of saying, all right, what it would multiply to give me 9/4 and adds to give me 3 halves, like if that's what you're thinking of, right? Okay, or 3, whatever. I made that up and it wasn't not that great. Okay, so go ahead and solve this by square rooting. We learned that method because now you can do that. So we have x plus 2 x plus 2 equals plus or minus, and we don't know the square root of 5, so we're just going to leave it as root 5, okay? And subtract 2 from both sides. So we have x equals, we're going to write down that -2 first, and then plus or minus root 5. This is as far as we can go because we can't combine like terms. And there's your answer. Okay, so once again, get a lead coefficient of 1. Complete this square by taking half of b and squaring it, and then adding that to both sides. Factoring the left-hand side, simpling the right-hand side, and then solving using square roots. That's it. All right, we have 2 more examples to do and the rest for you to try on your own. If you want to pause the video and try this one, since it is another lead coefficient of 1, go ahead and do that. If not, here I go. All right, so a value is 1. I don't have to divide everything by 1. Instead, I'm going to start to complete the square. I'm going to get the constant on the other side. So x squared plus 6x, I'll leave a space to complete the square, equals 8. All right, now I'm going to complete this square. I'm going to take half of b, which is 3, and square it. That is 9, so I'm going to add 9 to both sides. And now I'm going to factor the left side. This is x plus 3 quantity squared. X plus 3 times x plus 3 equals 17. And now I'm going to square root to solve. So square root both sides, plus or minus. You have x plus 3 is equal to plus or minus root 17. And now I'm going to subtract 3 from both sides to get x by itself. So I have x equals negative 3 plus or minus root 17. Okay, now. All right, we have one more problem, and then there are, I think, 8 for you to try for practice. All right, so this one is a little bit different because this one does have an a value other than 1. So it's not much different. You just have to start by getting the a value to be 1. So you're going to divide by 2. But when you're dividing this side of the equation by 2, you have to do it to the other side. And then you also have to remember to divide every term by 2. So we have x squared plus 4x minus 7 halves equals 0. All right, so now the steps from here are the same. So add 7 halves to both sides so that you can complete the square for x squared plus 4x. Leave a space to complete the square. Take half of b, half of 4 is 2, and square it. So that is 4. What you do to one side, you have to do to the other. Factor the left-hand side, that's x plus 2 quantity squared is equal to. I want to combine these two, so that's 8 halves plus 7 halves, which is 15 halves. Or if you need to see that, let's put this over 1, multiply this by 2. That's 8 halves plus 7 halves, which is 15 halves. And now you can square root to solve. So square root plus or minus, square root plus or minus. We have x plus 2 is equal to plus or minus, and then now I have the square root of 15 halves. So we can't leave it as the square root of 15 halves because you can't leave a fraction underneath a radical. So what we have to do is what's called rationalizing. So we are going to square root the numerator and square root the denominator. If the denominator was like root 4 or root 9 or root 16 or root 25 and we were able to square root that and then we'd be done, because our rule is you can't have any radicals in the denominator either. So no fractions underneath square roots, and you can't have any radicals in the denominator. So what we're going to do is we're going to rationalize. To rationalize, we're going to multiply by that radical in the denominator. And then that becomes, so we have x plus 2 equals plus or minus. Multiply these two, that's the square root of 30. And then multiply these two, that's the square root of 4, which is 2. Now it's a whole number underneath there, which is fine. And that's what it needs to be. Also, if root 30 was simplifiable, like root 27 or root 50, we would simplify it, but root 30 is not simplifiable. All right, we're almost done. We just need to get x by itself, subtract 2 from both sides, and we have x equals negative 2 plus or minus root 30 all over 2. Now, of course, to solve this quadratic, you could have also used the quadratic formula, which personally I probably would have preferred, seeing that not everything was divisible by 2. This 7 wasn't. But the directions say by completing the square, so I had to follow the directions. Okay, so why don't you go ahead and pause the video so that you can try. Let's do one at a time. Pause it, look at the answer, pause it, look at the answer. All right, here's the first one. So the first one, the easiest method to solve this by is square rooting. Nice and easy. Add 5 to both sides, square root. Don't forget to plus or minus. So you get 2 solutions, 5 and negative 5. The next one, the easiest method to solve it by is completing the square. And the method I would solve it by is completing the square. You get x is equal to negative 8 plus or minus 2 root 2. Negative 8 plus or minus 2 root 2. That root 8 right there is simplifiable, so make sure you didn't leave it as negative 8 plus or minus root 8. All right, the next one, nice easy factoring problem there. You get x equals negative 8 and x equals 3. All right, the next one, I will argue till I'm blue in the face here. I think quadratic formula is way easier than completing the square here. Not only does it have a lead coefficient of 4, but 4 is the only thing that's divisible by 4 there. The negative 6 is not divisible by 4, either is the negative 1. So it's fraction crazy. So completing the square is something that you can use, right? It's possible. I don't love it. It's just a lot of fractions, a lot of room for error. So I'd have just used the quadratic formula and gotten the same answer. But if you need to look at that closer in case you made a mistake, dividing everything by 4 first, you get fractions. Then b divided by 2, you work with fractions that you still have to square. Rationalizing is not bad because when you square it, the numerator squares the denominator becomes just 4. So that actually is not a big deal. But quadratic formula, I feel like it was easier for me. All right, next one, factoring. Pause and try the next. Next one, solving by square rooting. You get 4 and negative 2. Nice, easy one. Pause the video. Next one, using u substitution and then factoring. Get negative 1/3 and 1/2. If you got to this point, just be careful. After that, adding 1, dividing by 4, or adding 1, multiplying by 1/4. And then the very last one, it was factorable. It had a GCF of x. And then you could factor the trinomial that was left behind, the quadratic trinomial. You end up getting 3 solutions for this cubic function, 0, negative 2/3, and 1/2. All right, that's it for these notes for today. If you have questions, please ask.